if you build with language models. This matters because the weak point is usually not generation. It is selection. Models can produce several plausible answers, but a product still has to decide which one to show, or whether to hold back. This tutorial focuses on that decision layer. The setup is simple in concept: generate multiple candidates, score them with an internal critic, estimate uncertainty, and choose a response with a risk-aware policy. That is useful because many current agent demos still treat the first answer as good enough. This tutorial says that is not enough if you care about reliability. It also reflects a broader shift in AI products. The value is moving from raw output quality to better control over confidence, consistency, and safety. So the question is not whether the model can answer. It is whether the system knows when an answer should be trusted. The article describes a tutorial pipeline rather than a new foundation model. It starts with structured containers for responses, critic scores, and uncertainty estimates, using data classes to keep the system organized and reproducible. Then it emulates a language model that can produce several candidate outputs with temperature-driven variation and controlled noise. That matters because self-consistency only works if you have multiple samples to compare. On top of that, the tutorial adds an internal critic that scores each answer across accuracy, coherence, and safety, then combines those into a weighted overall score. After that, it computes uncertainty signals like entropy, variance, and consistency, plus a decomposition into epistemic and aleatoric uncertainty. Finally, a selector chooses a response using strategies like best score, most confident, most consistent, or risk-adjusted ranking. So this is really a full orchestration recipe for multi-stage decision-making, not just a prompt trick. The interesting part is the tension between quality and confidence. A candidate answer can still carry high uncertainty, or it can be very consistent across samples, but not actually be the strongest answer. The tutorial tries to formalize that trade-off. It does not just ask which response looks best. It asks how much risk you want to accept when picking it. That is where the risk-adjusted selection logic comes in. More conservative settings can prefer lower uncertainty outputs, while more aggressive settings can chase higher scoring ones even if the confidence signal is weaker. This is a practical framing because real products make this trade all the time, whether they expose it or not. A coding assistant, medical summarizer, or support agent may need very different thresholds. The tutorial's main contribution is to turn that vague product judgment into explicit scoring and policy logic. The solid part is the system design pattern, multi-sample reasoning, critic-based evaluation, and uncertainty-aware selection fit together in a coherent way. The tutorial also gives useful vocabulary for thinking about failure modes, especially by separating consistency from actual confidence and by distinguishing kinds of uncertainty. But there are clear limits. The article describes a simulated language model with controlled noise, not a benchmarked production deployment. The critic itself is another judgment layer, which means its reliability becomes part of the problem. Weighted scores for accuracy, coherence, and safety can be practical, but they also encode assumptions that may not transfer well across tasks. And while the conclusion calls the architecture production ready, the source text does not show hard evidence like real-world error rates, latency trade-offs, or cost impacts. So the pattern is credible. The stronger deployment claim needs more proof than this tutorial summary provides. For builders, The shift here is that reliability is treated as an architectural layer, not a model trait. Instead of hoping a better base model solves trust, this tutorial shows how to wrap generation inside a process that samples, critiques, measures uncertainty, and applies policy. That is a useful product lens. It means you can tune behavior by changing selection strategy and risk tolerance, not only by swapping models. It also suggests that agent quality should be evaluated at the workflow level. A strong answer is not just fluid text. It is an output that survives critique, looks consistent across samples, and fits the acceptable risk threshold for the task. That does not remove the need for external evaluation, but it does make the decision path more legible. And that is probably the real signal. Here, more AI systems will be judged by how they handle uncertainty, not just by how confident they sound.